Okay, we're going to start coding now, and we're going to do some exercises that are actually kind of simple and kind of funny, and they may not even seem like they have any purpose. But I'll tell you that what we're about to do is one of the most fundamental skills of computer science, and you're going to do it so often in your career that it's going to become like speaking to you. It'll be so natural. And so if we can just do that in an easy, fun way right now, it's going to make the rest of your computer science career a lot easier. I'll go ahead and put up the timestamps here so that you can skip to a specific language if you're trying to learn a specific language. If you're a computer science student or a student wannabe, maybe potentially you're going to college in the future, or a boot camp, or maybe you just want to learn how to program. I really recommend watching all three programming languages back to back. It will take a little bit of time, but it will help you to gain a perspective that a lot of high school classes or college classes can't give you because they're focusing so much on the syntax of a specific language. Now, I recommend that you only try to code in one of these languages. Don't try to learn all three of them at once, unless you really want to. But it would be good to watch it so that you're aware. This class that we're teaching right now, we're covering kind of the material that you'll get in the first two classes in college. And we're covering it in a way that's kind of easy, and we're not drilling it into you like they would. They'll go through much harder exercises, and you'll have people grading your exercises and walking you through more complex situations, and so you'll be able to make cooler programs in college than what we're going to do. But if you want just an intro and you want to be really prepared for that moment when you get to it, this is an excellent class for that. And just another thing to say before we actually get coding, if you see a cut in here, just know that we're doing all these demonstrations live, and sometimes when we go back and we tie it all together in the editing process, I'll realize, oh, that took a little bit longer than I meant to describe. We could have done it in just those few words that I first said. So we're just going to cut over and try not to waste your time. And that's what we're trying to do with all those. So let's not waste any more of your time and head straight into the exercise. Computer science, the golden arena of endless well-paying jobs, needs problem solvers from all backgrounds, but appears surrounded by a thick wall of incomprehensible ones and zeros, self-righteous nerd minions, and endless differential equation nightmares. This video textbook attempts to create an entrance through that wall by teaching programming basics in the language of real people. This video is a real-life coding example in 3 different languages. To view this week's lecture on programming methods, click here. And to watch this week's lecture on computer science beyond just normal programming, click here. Okay, so now we're going to actually start coding, and we're going to choose, for the exercise, what we're going to do is choose an object from real life and try to find 5 points of data that we can record. We're going to take something from real life and translate it into computer language.
Okay.
Okay, so you're going to start off. What do you want to translate?
How about a dog?
Let's do a dog. Okay. So first go to Visual Studios. And wait for it to load. And then we're going to create a new project.
Create a new project.
And we're going to do a console app, so it's the second one down.
Do I need to click on anything else?
I think that, oh yeah, just a double click it looks like.
Cool. What should we name it?
Let's name it dog data, all one word. Beautiful.
Okay, anything else?
Nope, let's hit create. Okay, so you have a ton of code in here already. All of that green stuff, let's delete that.
Not the...
Yeah, not everything else, just the green stuff at the moment. All those are like sticky notes that programmers leave.
Okay.
And then we're not gonna use that hashtag include IOStream on line 2.
Mm-hmm.
Well, let's not worry about that. We'll talk about that next week, but that's not important.
So I should take it out?
Yep.
Cool.
But there is a standard practice for when you're using C++, and we will talk about it briefly later on, but just know that it's got to be included in most of your code. It doesn't necessarily have to be, but it's a good practice too.
Okay.
Type down using You'll just have this at the very top of your code. Using space, namespace, all one word,
Okay.
std. And don't laugh about that. Semicolon. And that's just telling them that when we bring in tools from the language itself, that we want the default version of those.
Oh, okay.
So that's what
Don't do-
STD stands for standard.
Don't give us any crazy stuff.
Exactly. And then if you look inside here, we've got this weird line on line 4 that says int main. That's just telling C++ that everything within these two brackets, within bracket on line 5 and the bracket on line 7, is the main part of the program that we're going to run.
Okay.
So this is, I'll show you later on how to write sub-programs that you can put outside of this and then call when you need it. But at the moment, everything within these two blocks is what the program's going to look for when it starts running.
Okay.
And you can delete that line on line 6. And that's where we'll start coding.
All right.
Okay. So what's the first point of data we should... Do you want to do the breed? Or the name?
Name.
It's height. Okay, let's do a name. So that would need to fit into some kind of container that can hold the letters all together. So that would be a string.
Okay.
Okay. So what we're going to do is type down string, just to let it know what type. And is the name changeable?
No.
Okay.
So it will be a
It'd be a constant. So before the string, what happens is C++ just assumes that everything's going to be a variable unless you use the constant keyword.
That makes sense.
So before the string, I think it's before. I'm pretty sure it's before. I always forget and then it reminds me. You're going to type const instead of, just const, just like that. Yep, space. And there you go. Okay, it's looking good. Okay, now what you want to call this point of data is probably name.
Yeah.
Okay, or dog name. You could do that if you want.
Okay. Dog's name.
Dog's name. Yeah, that would work. So a programming convention is when you are doing constants, you're going to keep everything in caps lock.
Okay.
And that way, whenever you see that pop up, you know automatically that this is something that the data doesn't change inside.
Okay.
Okay, so you do dog, or dog s, dogs, and then do an underscore to start a new word, and then name.
Like that.
Okay. Now we're going to bring out the assignment operator,
Okay.
which is the equal sign.
Do I need a space?
The computer doesn't care if you do, but it's kind of a good programming practice just to do.
Okay.
Just makes everything look clean.
I like spaces.
I do too.
Okay.
And then use quotation marks. Strings are kind of denoted by quotation marks, and you can use single quotation marks or double quotation marks like you're using. And everything inside of that will be the string.
Okay.
So whatever your name is.
And yeah, never mind. I need all caps still.
Oh, actually, you don't.
Right?
Sorry, that's just on the.
That's just on saying that the dog's name.
Yes. So the name of your box is right here.
Okay.
This is
so that box. Okay, that
the
makes
type
sense.
of box. This is the style of box.
Okay.
Yep.
And
And
this
then
is
the
just the
data can be whatever you want.
information.
Yep.
Okay. How about spot?
Perfect. And then when you're done writing a command, you'll put a semicolon. Oh, right there. Perfect.
Okay.
Now there's only one problem with this, and I bet you can guess where it is. It's right under the string. It's saying identifier string is undefined. Basically saying that it has no clue what a string is, which is really silly. But strings in C++ are not automatically included because they're so expensive.
Okay.
So they think if you're going to write a program that just has numbers, we're not going to include the code for strings. So one way to fix that is to hit Alt, Enter. And this is anytime you get a red squiggly.
Okay.
You can hit Alt, Enter, and it will suggest a few things. So these are all suggestions. You could you could change the signature. I'm not going to explain what all this is because this is kind of a little deeper than you want to go. But just add include string. And what that did was it copied all of the code for strings into our code.
So we don't have to worry about saying, hey, this is all the details of a string. Please do this. It's there if you want to do it. You just have to know to look for it.
Exactly. Okay, let's go to the next point of data then.
Can I push enter?
Enter, start a new line. Yep, perfect. Okay, now what would you like to do?
We can do the breed.
Okay, let's do the breed.
Which is also a constant.
Mm-hmm. Yeah, that doesn't change.
Would it still be a string?
I would think so, yeah. Yeah, okay. Let's do a string.
No red squiggly. Let's see. Dogs breed.
Yeah, sounds great.
Underscore. How do you spell breed?
I think it's B-E. Or at least that's how it is in my mind.
Breed. Okay. Equals and quotations?
Yep. Exactly. Man, you got that fast.
What is the dog's breed?
One that's easy to spell. Don't do Weinreinler.
Let's just say lab for short for Labrador.
Okay, great, because I can't spell that either.
Okay.
Okay.
Enter.
Mm-hmm.
Let's see. Color?
Let's do color.
Okay. So, I guess that's
also constant.
That's also constant.
Yeah, and that's data that doesn't change. It's also a string. You're making it easy.
Ooh, we got a squiggly.
Mm-hmm.
Do I need to worry about that right now?
You don't have to worry about it right now, but if you want to address it right now, we can.
Okay.
Sometimes I like to finish writing what I know and then go back and be like, okay. Because sometimes it will give you a warning sign before you're done typing, and you'll fix it when you get done typing.
Okay, yeah, that makes sense. Okay, so caps lock, we color. Dogs color.
You were good at this. It's just really good to get like systems in place just so that everything's always organized. It's so much of computer science is just about staying organized.
We're gonna have a silver lab. Do those actually exist? I don't know.
They can in a computer.
They're existing here if they don't. Silver.
Okay.
I guess we want to fix this. Is it because it's indented?
Partially because it's indented, but it's also wave your cursor over it again, over the squiggly. It says expected a semicolon.
Oh, was I was supposed to do that up here then?
Yep.
And I guess I need to do that here too.
Mm-hmm. And you see it automatically got rid of the indenting.
Fixed it. Okay. Yeah. Cool.
Yeah.
I did forget that. Okay.
Easy to forget.
Let's see. Our dog's name is Spot. He's a lab, and his name's Silver. But I'm guessing he needs to have spots if his name is Spot.
Okay.
So, should we say spots, yes or no?
Yeah. Does he have spots?
Yes,
yeah.
he does.
Or is spotted?
Has spots?
Has spots. That works great.
Okay.
Let's do that.
So.
It's also constant.
It's also constant.
Right?
Const.
And
This is a different one, isn't it?
This is. I'm trying to remember. This is one that can be either yes or no, or true or false. Right? Okay. This is a true or false question.
Yeah.
And those are called booleans, or in C++, they just shorten it to bool. So B-O-O-L. Yeah. There you go. And you can see it's a different color because that is actually that's a data type or a box type that it automatically recognizes. You remember with string we had to import the...
Yeah, it didn't recognize that immediately.
Exactly. It recognizes this immediately.
Okay.
Yeah.
Now, since... Oh, this is still constant, so I do need caps lock for this. Has spots, right? In one word.
Yep. Has spots.
Has spots.
With an underscore in between them.
Oh, yes. Okay. equals.
And you can just write the word true.
Do I need parentheses too?
Nope, no parentheses, no quotation marks, just true.
And
Perfect. Now, this doesn't make a whole lot of sense to do right now, but there might be a moment or two that will pop up later on where you'll be like, oh, that would be really cool if I could just do that. You could also do, instead of true, you could also write just 1. And C++ will let you do that. Not every language will do that.
Like you were saying in the video, 1 is true.
1 means it's on, 0 means it's off. Exactly.
True, false. Okay.
So you can just put the straight binary into it if you want, but you could just write true.
Okay, we'll just do that for this.
I think best practice is to do true unless you really want to do some kind of math with it.
Okay.
And actually you can write true and it's still just storing a 1, so you can do true and then still do math with it later on, but that's
Okay.
way more information than we need to worry about right now. Let's try to do something variable.
Age.
Age. Yes, let's do age.
So that would be int.
Yeah, you could do it as an int if you want it to be just a whole number, or if you want to do like halves. If you want to do like, oh, she's 7.5 or something like that, you could do a float.
Ooh, let's do a float.
Okay, do a float. And so here you can just write float because it's going to assume automatically that you want to be able to vary it.
And
so you don't have to write variable or anything like that.
And this wouldn't be a bool or a string.
No.
I'm trying to remember what this one would be.
This is actually automatically,
Or
because we just
a float.
didn't include the const, so we're shifting over where this would be your box type. This one is actually your box type now.
This varies. It's variable, so you don't need to state
Exactly.
that because it automatically assumes it's a variable.
In some languages, in fact, all the ones that I'm about to demonstrate, you have to include var instead.
Okay. But for C++, it recognizes if you don't say anything, it's a variable.
Exactly.
Okay.
Yep. These are just the little subtle differences between languages, but ultimately the thinking behind it all is the same. Okay.
So now that this isn't a constant, it doesn't need to be in caps.
In fact, there's a really weird case that you use for variables.
Okay.
It's called camel case.
Camel, like humps?
Exactly.
Oh.
So what you're going to do is type down the first word in lowercase.
Okay.
So you'd say like dog.
Dogs.
Dog's age, maybe. Dogs. And then do a capital A for age. And then GE. Just like that. And every time you start a new word, you capitalize it.
That's why... Is that why when there was the box saying, is there ice cream in the fridge, the first letter wasn't capitalized? Okay.
Yep, that's camel case.
Picked up on
Good
that.
job.
Okay.
Anyone who's watching, if you go back and look at the object box, the code for the object box, you'll notice that there's a constant that isn't capitalized. And I saw that after we animated it. And I was like, no. But we didn't go back and fix it, so.
Also, with this one, there's not a space.
No.
An underscore in between words.
Exactly.
Okay.
And you might see a language that does it differently, but generally speaking, that's true for just about any common coding language.
Okay.
Constants are always capitalized with underscores. Variables are always camel case.
Okay.
Yep.
So, space and equals.
Mm-hmm. Yep.
And
you can just type down the number.
Equals. How about 2.5?
2.5. Let's do that.
2.5?
Yep. Perfect.
Semicolon.
Mm-hmm.
Now, we technically have 5 things, but for demonstration purposes, should we do another?
If you'd like to, yeah.
So we can show another.
Yeah. A different type.
Different type.
Yeah.
What other types do we need? I think, is there one more that
there's one that we didn't do.
About?
Yeah, we did. So you can do an int, a float, and a double, and those are all numbers, and they're all similar. They really act similar. You could do a char, which is just a single letter.
Okay.
You could do his obedience school grade or something like that.
Okay, let's do that. That
Okay.
sounds good.
Okay.
So char.
Char. Yep.
And any special rules here?
Nope. Nope. No special rules. Just camel case. So this is one. Is this one that you want to be able to change? Because maybe it will change week to week. Maybe he's already
Yes.
in.
Yeah.
Okay. Yeah. So you would go ahead and leave that as a variable, and then
Okay.
you'd use the camel case to write the name.
So grade in school or
Yeah.
school grade?
Yeah, you can do school grade. Beautiful.
Equals. Nope. Equals.
Mm-hmm.
Now, can I do an A plus or just A?
I think it just has to be an A. You could do an
Okay.
A plus if it was a string, but you can't do that as a char.
And then
Okay.
it has a squiggly.
Let's go ahead and back up to the squiggly.
Is it because I capitalized it?
It should be able to do both,
Okay.
but I think it wants quotation marks. I'm not sure though.
Oh.
Do the Alt Enter. It's
Alt
been a while since I've used a char.
enter.
Change signature. Try it with quotation marks. Just see if that does. That fixes it. I was hoping that it would give you a. Well, that's a little strange. Try it with single quotation marks. I'm glad we talked about this. That's it.
Oh.
C++ is weird and just wants single quotation marks for chars.
Oh, okay.
Yep.
Single quotation marks for chars.
Weird. C++ is really picky about things like that.
Hmm.
Okay. And then I want one more line of code.
Okay.
This is how you end a C++ program.
Okay.
Inside main.
And this is, yeah, so all inside
Yep.
this area.
Exactly. Exactly. So go ahead and give it a space. Kind of like paragraphs in a.
This is one thing, this is something different.
Exactly.
All in the big thing.
Exactly. Yeah. You separate code. There isn't a hard defined rule on how you do it, but you separate code just like you would separate paragraphs in a paper.
That makes sense.
Just make it easy to read.
Cool.
Okay. And then you are going to write return 0.
All in one?
Space 0, sorry, and then a semicolon.
Semicolon.
And what's going on there is it's saying this is the program, and this int, when you get a returned int, then you'll know you're at the end of the program.
Okay.
That's what that thing is. And this is the int that we're returning. We're returning 0
Okay.
to let it know we're
turning
done.
off. We're done.
Yep, we're turning on. That's really weird, but C++ is kind of an older language, and it does things
On,
like
off.
that. Yep.
On, off.
So now let's try to do something kind of cool. I want to see the computer actually store this in memory.
Okay.
And I'm going to try this. I'm trying to remember how to do this, and I hope that it works out well. Go to Debug. It's a tab up here at the top of the screen.
Oh, debug.
Debug, yep. And then go to
Start debugging.
Step Over. So it's
Right here.
right there, yeah. These are tools that help you to figure out where bugs pop up in your program, where you're running into problems.
Okay.
And so it's going to run through each line of code, and hopefully, so that's the console that just popped up. We can drag it and move it out of the way. We don't need it necessarily. And hopefully it's going to give us a little tiny readout of all these variables as they change. Okay. Let me kind of changed the interface a little bit since last time I was here. Step into, step over. Okay, so we're on this line of code right here, and it's waiting for us to say, okay, we're ready for the next. Go ahead and execute the next line. Let's execute the next line. Let's see. Oh, here, let's go to, is it watch or locals? There we go, locals. So it's saying, oh, here's this thing. There's no real value in it that we can understand. Let's see if we step over and go to the next line. See if that changes. Oh, there we go. So it just stored spot.
Oh, okay. So it had to go through one in order to really understand it.
Sometimes you have to step past the step that you want to figure out before you understand what happened in that step.
Okay.
A lot of times the computer just doesn't know. And if you can look in here, dog's age, that is a garbage value. That's not what we put in. That's just what's currently...
How it stored it.
Yeah, that's what's currently on the shelf in the memory slot where they're going to store it.
Okay.
Because it hasn't been defined yet.
Gotcha.
So it's... Right now it's like, oh, yeah, there's a spot on the shelf for a float, but we haven't defined the float yet, so because we haven't run that line of code.
Okay.
So we just looked and there was a box and it's just garbage there. Okay, and it just changed to lab. We just changed to silver. We just changed to true. And you can see the same right here. It's like, oh, it took the binary that was already on the shelf there. And they leave binary on the shelf because they don't come back and clean it up unless you tell it to go back and turn everything to zeros.
Okay.
Instead, so this is just whatever was on the shelf back then. And maybe it wasn't a 52. Maybe they weren't trying to store that. Maybe they were trying to store something else. But they had at least this many ones and zeros that it looked like a 52. And a 52 in the encoding that we're using actually turns out to be an L or an I. Looks like an accented I.
Okay.
So anyway, we'll step over. And there we go. That changed to our float. And that changed to A.
Cool.
A is 97 in binary. And our program's done.
Okay.
Cool. And you can see once the program ended, it just said these values are no longer attached to these names.
Okay.
Yep. Okay. Cool. So there you go. You have just programmed.
Nice.
Thank you.
Yeah.
Okay, let's do some JavaScript programming. But before we do, I want to just kind of demystify a little bit of computer science. I don't know about you, but for me, one of the hard things about computer science is that there's so much that I don't know. There's so much out there that is going on behind the scenes, and I want to see the whole iceberg, and I'm really just getting a tip of it. And that's hard for me. I want to be able to form a complete mental map of what's going on. I don't feel like I can really say that I understand something until I get to that level. Now, maybe you're not like that, and if you're not, that's probably a good thing, because that holds a lot of people back from learning programming, because there is so much behind the scenes. I want to maybe at least remove a little bit of that layer of confusion and just show you that there's not a whole lot of extra magic going on behind the scenes on some of these things. Now, I'm going to open up another IDE. Right. Okay, so this is just a simplified version of Visual Studios. And I'm going to open up a new file, and I'm going to type in some JavaScript. Now, you don't need to worry about what I'm doing here. Let cheese equal Swiss. Okay, and this is totally valid JavaScript code right here. I'm going to save it. I'm going to let it know that it is not JavaScript React. It is actually straight JavaScript. Where is straight JavaScript? TypeScript, that's... Well, I know that it's JavaScript. I'm not finding it. Maybe you see it and I don't, but I know that all you need to do to create JavaScript is type this .js right here, and that will tell the computer that this is a JavaScript file. And you'll recognize it because it says right down here, JavaScript. Okay, so there you go, and it's recognizing it now as JavaScript code. It will highlight keywords. See, if I type in var, it will highlight that, and it will say, oh, that's a keyword I know. Okay, oh, and it will give me little error messages if I'm not doing it correctly. So this is now a completely valid JavaScript file. But I want to show you that you can do the exact same thing just on Notepad. There's nothing special about this that makes this code. Let me go to let's say let cheese 2 equal, what's another great cheese? Gouda. I don't know how to spell Gouda. Is it Gouda? Is it Gouda? Is it like that? Maybe we'll just do cheddar. Cheddar's another good cheese that I know how to spell. Maybe. Maybe I don't know how to spell cheese. I think it's with an A. Okay, and now I'm just going to save this, and I can do the exact same thing where I type in cheese 2.js, and it will save as a completely valid JavaScript file. And to show you that, here is cheese, and you can see it's recognizing it as a unique file type. I'll wave over and it says JavaScript right there. And I'm bringing over cheese 2. This is the one we did in Notepad, and it's the exact same type of file, almost the exact same size. 23 bytes, 22 bytes. Okay, so what I can also do is I can just drag this into here, and you'll see that it's recognizing it as JavaScript code. So there really isn't any magic in having an IDE. There is, because the IDE will look at it and say, oh, hey, this is JavaScript code. I can tell you where you're doing things wrong. I can kind of read it a little bit better. But you could do all this coding on Notepad if you wanted to, save it as the correct file format. And what's going on is when you actually run this, it's going to go to an interpreter of some kind that is going to change that. It's going to change that code in English language or in JavaScript language and change it into binary that your computer can understand. Okay, so I'll leave those on. We aren't going to use this tool because it's actually, I can show you right now, it's kind of hard to get this. It's extra steps. I won't say it's hard, it's just extra steps to get this to open and run. I can try to open it in Chrome, but it's not going to open and run as a JavaScript file. Instead, it's going to just display as if we were reading it as a text file. See, oh, there you go. See, that's not really useful for us. So what we're going to do is going to use a website that already has it, an interpreter built in. So let's go to playcode.io. And it opens up directly onto a JavaScript project. And I think you can create an account and it can save and stuff like that. But I'm not going to do that. You can do that if you want. I'm getting rid of that intro thing because I don't need it. Right here, it's showing how all this code right here would display as if you were on a web page. But there's a couple things that tie in to make this thing. So you have to have this CSS file. Actually it's a pretty easy code to learn, but it's a code that we're not going to worry about during this. That's a code that tells it how to display, what size of font to use, how wide should this be centered, things like that. And so we're just going to get rid of that and watch how that just changed right there. I'm also going to get rid of this style CSS because we're not going to use that. And we're going to get rid of this jQuery JS. And you notice that gave us a lot of errors right there. So it's not displaying anymore. That's okay because we're not going to display things quite like that. We're going to display things on this console. And so here, if I get rid of that, that gets rid of the error message. So anyway, the point of this is we're going to use this as simple as we possibly can, and to do that, we're going to get rid of any CSS, we're going to get rid of the jQuery library and everything like that. So you can just kind of strip it down, and this is the file that we're using, this script.js, and that's the same thing as if we were to name this script.js and save it. We're just editing it on a website, and this exists somewhere on another person's computer. It's an internet computer called a server off somewhere, I don't know, maybe in Greenland or something. So anyway, that's what we've got. We're just going to keep this script file and the console. Okay, now I'm going to get rid of all that code and let's start JavaScript programming. Okay, now you'll remember in C++ we had to do this int main thing, and we had to do this using standard. Let's see, using namespace standard std. Don't laugh about that. Okay, there we go. We had to do all that, and you don't actually have to do that with JavaScript. The nice thing about JavaScript is it's built to just run as simple as you need it to run or as complex as you need it to run. And if you're involved in a really complex project, it's actually a really good idea to bring over some of those coding conventions from C++, where you do have a main program and stuff like that. But if you're doing really simple things, it's kind of okay in JavaScript. It's not as frowned upon in JavaScript to do quick band-aid fixes if you need to. And JavaScript will run just fine if we don't have a main program running. So we're just going to go ahead and put the variables straight in as it is. And that is kind of bad practice, but it's allowed in JavaScript if we are just doing simple things. So since we're doing just simple things, let's go ahead and I'm going to describe a sandwich. And one of the things that JavaScript does really well, and it's kind of a great benefit and also a great detriment at the same time, it likes to guess what kind of box we want. And you can go in and you can do some tricks to kind of tell it, hey, whatever box we put it in, we want it to be specifically this one. But JavaScript will do a lot of the guesswork for you. It will say, hey, that looks like a string, let's put it in a string box. Or that looks like a boolean, let's put it in a boolean box. Or that looks like an int, I'm going to put it... Actually, they don't have ints in JavaScript, at least not the way you'd think about them. They have a numbers box, and just everything that you want to put inside that box goes into that numbers box. So anyway, we're going to go ahead and let's do a constant. I'm going to describe the bread of the sandwich. So to do a constant, you put that const keyword in, and you don't actually have to specify what type of box you want. So the next thing you're going to put in is the name. And because it's a constant, I'm going to, there we go, put everything in caps lock. And then to specify that I'm using a string, I'm going to use quotation marks. And the bread was sourdough. This is a sandwich I ate not too long ago with sourdough bread. Now, you notice I didn't put a semicolon here, and you totally can. And I sometimes do because that's kind of, I grew up, or I learned to code when semicolons were kind of a big thing, and they're dying off. You don't need semicolons in a lot of modern languages now. So we are going to, we're going to just omit that. It's not something that's necessary, but you can put it in there if you want to make that a habit, if you're coding in languages that require them. And then let's do the cheese equals, this was Havarti. Okay, great. Another constant. The meat equals ham. Okay, great. Now let's do a variable. I'm gonna put a boolean in, and it is going to be the question: was it a grilled sandwich? And when you do booleans, not all the time, but most of the time, you try to make the name a question, kind of like we showed in the video, and that just is a coding convention that makes it really easy to tell when something's a boolean or not. And you can just ask the question. It makes sense. It will make more sense the deeper you get into programming, I promise. Okay, so let's go ahead and add a variable. And there's two ways to do this in JavaScript. And the reason is because back when they developed JavaScript, they had you denote a variable with the var keyword. Now the var keyword worked for several years and was an important part of JavaScript. However, it does behave just a little bit differently than you'd expect a variable to act in a lot of other coding languages. And so there were some weird things that you had to do inside JavaScript to make variables act like variables are supposed to act. And I don't know if that was an intentional thing that the JavaScript people did, or if it was an accident. Maybe it was an oversight that someone did, and it just a little bug that popped into the language. But they came out with a new version of JavaScript in 2015 that had a different keyword that acts more like you'd expect a variable to act. And that keyword is let. And so you might see, and it's still very common to use var because a lot of JavaScript developers have been using it for years and it's just habit for them. And so you're going to see a lot of old code and a lot of current code that still uses var. But just so you know, it's known as bad practice unless you're trying to access those weird behaviors that the var keyword has that let doesn't. So the modern JavaScript programmer is going to use let most of the time. And so you probably should too. So we'll use let, and then here I'm going to use the camel casing again, where I start off with a lowercase, and then each new word I highlight, or I uppercase the first letter of it. Okay, and is grilled. So I've turned it into a question, and I'm not going to use quotation marks. I'm just going to use the keyword true. And there we go. And hopefully that has turned into a bool. And there's some code that we could type in to see that, but I'm not going to waste your time with that right now. And then I'm going to do one more bool. Is eaten. I'm not sure that eaten is a correct word. And sometimes correct English does not make it into your program. But you know what I mean, right? You know what I mean when I say is eaten. I will say true. Yes, I completely ate that sandwich. Okay, or you could say false. Now I'm going to test this and see. I don't know that JavaScript allows you to do that whole... Oh, yeah, because I believe if you were to put 0 or 1, it would just put it into the numbers box. And so I think you do have to write out true or false. True. Okay, there we go. Now let me show you one other thing. If you were to maybe sign in, I think code or play code would allow you to save this. But since I'm not going to do that, I'm not going to bother with making an account. What I'm going to do is copy and paste this into a notepad file and save it to my desktop as sandwich, and instead of this .text file, .js, I'm going to save it to my desktop, and that way I have it, and whenever I refresh this, I can just copy and paste my code into there. And there we go. I can start off where I left off last time. And that way I don't have to have an account. But you can create an account if you want to and let me know if it works or not. I'm not sure if you can even save code in there. But let's go ahead and move on to Kotlin. All right, let's go ahead and start Kotlin coding. I'm loading IntelliJ at the moment on another screen. I'll pull it over as soon as it's open. Okay, there we go. And what I'm going to do is I'm going to hit cancel on this. It's loading my last project. I don't want to do my last project. I want to kind of pick up from a fresh start. So I'm going to hit cancel. And it should bring open this window here. Now, before I get too far into it, let me remind you that I am not a Kotlin programmer. I'm teaching myself Kotlin as I teach you Kotlin. And so you may see a moment where the screen fades over to a new section. That probably means I went to go look up to make sure that I was telling you the exact, the proper way of doing things. Also, if you happen to know of a more efficient, more Kotlin way of doing things, then feel free to let me know. Okay, so I'm going to hit create new project. And we have two options here. We could go to Groovy, which is kind of that's a Java thing. And I'm not a Java developer either, so I'm not going to tell you what Groovy is exactly, but we're going to click on Kotlin/JVM. And what this JVM stuff is here, that stands for the Java Virtual Machine. And Java Virtual Machine is a program that usually comes on your PC is installed very soon afterwards, whether you're on Mac or whether you're on Windows, or I think they can even run it on Linux. I've never tried myself, but I think that it will even do that. The JVM is a small program that turns Java code into binary for your computer. Now, the nice thing about it is that they have written Kotlin in a way that the Java virtual machine can also read Kotlin code. So we're going to run Kotlin on the Java virtual machine, turning our Kotlin code into binary. Okay, so let's hit next. I'm going to create a project. I'm going to call it new sandwich. All right, now I'm going to hit finish. Okay, here we are. Now, you will see if you click on this project thing, this is a new folder. And if you were to follow this path right here from my C drive and go down into all the way to this this new folder right here, you would see that this has created a new folder, and inside lots of little folders. In fact, here let me just do that. Maybe we'll pause the video here while I go find it. Okay, here we go. I have just traveled down this path right here, and there is our new folder. And you'll see that there's more folders inside of it with little files. And those little files are just the same as if you were to write out something in here and then save it with that file extension. So not a whole lot of magic going on there. It just created a bunch of stuff. We're going to create, and if you were to make changes over here, it would be the same as making changes over here. In fact, this is just a different way of displaying all the information that's in here. It's a more convenient way of displaying it, really. Okay, so I'm going to go over here. We'll just use this side. And what I'm going to do is look for this folder, this blue folder, SRC. Okay, and we're going to right click on it. The SRC stands for source, and that is a common naming convention in programming. Kind of your main files usually go in a source folder or something like that. Okay, we're going to call this new sandwich. Man, now I wonder if I'm even spelling sandwich right. I'm not a confident speller, if you can tell. Okay, now this is not like JavaScript where you can just start coding. You do have to set up a few things, and we could talk about like using standard namespace. We're not going to put that in. We're just going to say, hold on, let me make sure I think it's fun main parentheses curly brackets, or just brackets. No, curly brackets, that's what those are called, right? Okay, there we go. And then that is basically the same thing that that Java or that C++ is looking for. And that's just saying, hey, this is where the big part of our project is going, is inside this main function. And that's what that FUN, it is fun, but it's also standing for function. And that's what these programs inside these brackets are called. And we'll have a whole lesson, and we'll spend several lessons actually talking about functions and how to write them, and how to write more functions than just this main function. But we're not going to worry about that right now. We're just going to put everything inside here. So let's go ahead and make sure I remember how to do this correctly. But in my research, it appears that val is the word that you use when you want to do a constant, and var is the word that you use when you want to do a variable. So let's do val, and then we're going to do, I believe the name comes next, so let's do bread. Just doing that same sandwich that I did for the JavaScript. Okay, bread, and we're going to do sourdough. And you can put that semicolon there, but you don't have to. Now you can already see we've done some things. IntelliJ is already trying to tell us some things. One, it's highlighted this in orange, which means, hey, I recognize that as a keyword. Okay, it is highlighting this in green, and that's basically saying, hey, I recognize that as data. We also didn't have to specify that it was a string. It knew, it kind of guessed, hey, we want a string. We could, if we're worried about the computer guessing incorrectly, what we can do is we can do a colon there, and then we can type in string. And I think string is the first letters capitalized in Kotlin. But then it also is giving us some squiggly lines, and that means, hey, something is redundant here. Basically, it's saying we're not using bread anywhere in our code. If we were to say, oh, let me change this. I'll say bread. Oh, here's what I'll do. I'll do a variable. Say buy more bread type. This will be a little weird. Okay, just bear with me for a second. If I were to say buy more bread type equal to bread, it would kind of get rid of that squiggly, or at least it would change it and it would say, hey, okay, so we're using bread. All right. So it's saying that we're not using it. So why do we need this code? It's asking me, why are you putting this code in here? Well, it's because I'm teaching a class. But otherwise, if I were trying to make a real program, it would say, hey, you don't actually need this code because you're not using it anywhere. Also, it's giving us that same little squiggly here because it's saying, hey, I already figured it out. You're using a string. I knew that because you put it in quotation marks. So you don't need to have this string here if you want to make things simpler. And Kotlin and IntelliJ really want you to be as simple as possible. That's what they were designed to do. So it will give you lots of those suggestions. Be like, hey, you don't need to do this. What is also, okay, I'm not quite sure what's going on with that. That's just our never use thing popping right back up. Okay, so let's go ahead and add the other ones in here. Bread cheese equals Havarti. I'm sorry if you get mic pops every once in a while. My finger is very close to the cord to the mic, and every once in a while that just bumps it. Okay, cheese, meat. We're gonna put ham, and then we're going to do var, and I'm pretty sure it's just going to assume that this is a boolean. We're gonna say is grilled. Oh, not that R there. Is grilled equals true. Just type it in, just like that. Var is eaten. Oh man, this is rough. All right, there we go. Is eaten is true. Okay. Now, I don't think that Kotlin, because it's also trying to assume a type, I don't think that you can put in a 0. Yeah, because that would be a little weird, but I'm wondering if maybe you can you can say, hey, make this a boolean, and then you can put 0 in there. First of all, it doesn't like the word boolean. If you'll notice this, it's giving you red saying, hey, I don't understand. And you can do the same thing in IntelliJ that you can do in Visual Studios, where you can hit Alt, Enter, and it will give you a couple options. One, it says, well, we can create a new type of box called boolean. But basically, this is all telling me that I've done this in a way that it doesn't recognize. I think what it wants you to do is just put a capital letter there. There we go. Cool. So now it recognizes that we want a boolean, but it's not allowing me to put 0 instead of true or false. So I'm just going to put true. There we go. Okay. And there we go. It's saying that's redundant. So if I wanted to be writing concise code, I should get rid of that. And there you go. That is a completely valid Kotlin file. If we wanted to run this, can we debug it just like we did in C++? I think we can. Hold on just a second. I'm going to hit build project. See if that gives me a debugging option. I'm waiting for it. You can see the progress down here. It's compiling. Compiling is a word for changing everything over into binary. Now it's giving me several warnings. You'll notice these are all, hey, by the way, you never used these. You declared them, but you never used them, and so they're kind of useless. But I think it says the build's successful, so let's go ahead and see if that gives us a debugging option. Well, we can hit debug. I might have to play around with this a little bit more. Well, I'll play around with it a little bit more, and I'll show you how to do this in later videos. Thank you for joining us for this week on Computer Science for Normal People. Enjoy your weekend.